What's up everyone, Patrick here, welcome back. And in this question, we're given this function 2x minus 5 over x minus 3. And we got to go through these three steps here. So number one, we got to find the domain and range of this function. And notice that this function is a linear over linear function. And notice that nothing can cancel out here. Everything is fully factored. And so this is the most simplified function that we can have here. And so because this is fully simplified and nothing can't factor out and nothing can't cancel out, notice that at this x value of 3, that's the first thing I want to comment on. Notice that that's going to be a vertical asymptote. Right? It's going to make, that x value is going to make the denominator 0. And because that x value makes the numerator equal to something else, it's going to equal 1. If we plug in 3 for x, it's going to be 1 over 0, and whenever you get a number over 0, it means that there's a vertical asymptote there. And so if we were to take this and to graph it, we would know that at an x value of 3, there's going to be a vertical asymptote. Now if you remember from advanced functions, we can get the horizontal asymptote as well. And the horizontal asymptote is, first off, you got to see which case is it. Right, so you got to compare the degree of the numerator to the denominator. I've talked about this in previous videos. And if the degrees are equal, then the horizontal asymptote is going to be at the ratio of the leading coefficients. So notice the leading coefficient in this case is 2. The leading coefficient in this case is 1. So 2 over 1 is going to be 2. So we know that at a y value of 2, there's going to be a horizontal asymptote. Now, another way to show that, the horizontal asymptote, is to actually, this is probably a more proper way to show it, is to see what happens as x goes towards positive infinity and negative infinity. And let's just combine them. Right, you could do both limits separately. I'm going to combine them here. So notice this is a limit at infinity question. And so what we do with this type of function here is we divide everything by x to the power of the highest degree in the denominator. So notice in the denominator, the highest degree is 1. So what we would do is we would take everything and divide it by x to the power of 1. Okay, so this and this are the exact same thing, right? Just took everything, divided it by x, all the expressions. Notice the x's would cancel out here. And so what we would end up with is the limit as x approaches plus or minus infinity of 2 minus 5 over x over 1 minus 3 over x. And then 5 over plus or minus infinity, 3 over plus or minus infinity, those are going to go towards 0. Right? And then we would end up with 2 over 1, which is just 2. So what that means is that as x approaches positive infinity, or as x approaches negative infinity, the y values of this function are approaching 2. Right? So there's a horizontal asymptote at y equals 2. There's a vertical asymptote at x is equal to 3. And then another thing we can do is we can get the y-intercept and the x-intercept. So to get the y-intercept, you could plug in 0 for x. So if you plug in 0 for x, those would cancel out. You'd end up with negative 5 over negative 3, which is positive 5 over 3. So positive 5 over 3, that's like, 1.67 around, which is less than 2. So that would be like here. And then to get the x-intercept, it's basically the value of x that makes the numerator equal to 0. So basically, when does 2x minus 5 equal 0? It's going to be at an x value of 5 over 2, or 2.5, right? Which would be over here. And so if we combine everything, the function basically looks like that. Okay, so from here, from this graph, we can find the domain and range of f of x. Now, you don't necessarily have to go through this and graph it, but I did want to show it to you visually, how it works. So the domain, in this case, is going to be what? X can be anything except for 3. Okay, or another way to show this is that x would be an element from -infinity to 3, not inclusive of 3, so there'd be a circle bracket there, or from 3 to positive infinity. Okay, so that's one way to show the domain. And then the range would be what? Y can be anything, but y cannot equal 2. Right? That's where the horizontal asymptote is going to be. And then another way to show this is from y can be anything from -infinity to 2, right? From -infinity all the way to 2, or from 2 to positive infinity. Right? So that's the domain. That is the range of this function here. Now, in number 2, what we got to do is we got to find the inverse of this. And I've gone through examples like this where we got a variable in both the numerator and denominator. So there's an actual process to do this. So what I'm going to do is I'm going to let this be y. And then what you do is you interchange the x and y values. So we would have x equals 2y minus 5 over y minus 3. And now what you got to do is you got to isolate for that y here. So what we can do is we can cross multiply. So x, y minus 3, and then we'd have 2y minus 5. Then we'd have xy minus 3x equals 2y minus 5. And then what I'm going to do here, I'm going to bring the -3x over. I'm going to bring the 2y over. So we would have xy minus 2y equals 3x minus 5. Take out a y. Divide both sides by x minus 2. We would end up with y equals 3x minus 5 over x minus 2. Instead of putting the y, I'm going to put that proper notation like that. Okay, so this here is the inverse for that function right there. Just going to make sure that I did everything all good here. Yeah, it seems all good to me. Right, so that's the inverse of this function. And now what we got to do, we got to find the domain and range of this function here. So if we actually follow the exact same steps that I did before, notice we got a linear over linear function again. So we know at an x value of 2, vertical asymptote, ratio of the leading coefficients 3 over 1 is 3. Notice that at 5 over 3, that's where the x-intercept is going to be, which is going to be over here. 5 over 3 is less than 2. And then the y-intercept is going to be at -5 over -2, which would be 2.5, which would be over here. And so if we draw that, it looks like that. Okay, now what's the domain and range of this going to be? So the domain is going to be x can be anything except for 2. Right? Or another way to write it, x can be anything from -infinity to 2 or from 2 to positive infinity. And then the range, y can be anything, but y cannot equal 3. Or y can be anything from -infinity to 3 or from 3 to positive infinity, like that. So that's the domain and range of the inverse. And notice, how does the domain and range of the inverse relate to the domain and range of the original function? I don't have the domain and range written for the original function, but if you look at it, it's interchanged. Right? The domain for the function was x cannot equal 3, and the range was y cannot equal 2. But for the inverse, it's interchange. Right? The domain x cannot equal 2, and the range y cannot equal 3. Right? So that's another thing to note of. Right? So that's how you deal with a function, a linear over linear function, getting the domain and range, and getting the inverse.